Before solving the problems, let us know what is the principle behind the series and parallel combination of capacitors. The capacitance C1, C2, C3 connected in series, that is equivalent to a single capacitor of capacitance C. If Q is the charge on this equivalent capacitor, then Q is the charge on this capacitor, Q is the charge on this, also on this. If V is potential difference across the effective capacitor, V1 is the potential difference across first capacitor, V2 is potential difference across second capacitor, V3 is potential difference across third capacitor, then V equal to V1 plus V2 plus V3. This is the principle behind the series combination of capacitors. This capacitor, this one and this one, they are connected in parallel. Capacitance C1, capacitance C2, capacitance C3. This parallel group of capacitors is equivalent to a single capacitor. If V is potential difference, across this effective capacitor, then V is also potential difference across first capacitor, second capacitor, third capacitor. If Q is the charge on this effective capacitor, Q1 is the charge in the first capacitor, Q2 is the charge on the second capacitor, Q3 is the charge on the third capacitor, then Q is equal to Q1 plus Q2 plus Q3. This is the principle behind the parallel grouping of capacitors. So given 3 microfarad capacitor, 6 microfarad capacitor and a 10 volt battery, the capacitors are connected in series and then parallel across this battery. Capacitors are connected in series, that group is connected across the battery. Q is the charge, here Q is the charge, here also Q is the charge. Potential difference V1, potential difference V2, potential difference V equal to V1 plus V2. Energy stored is U1, energy stored is U2, energy stored is U equal to U1 plus U2. Q is equal to CV. So it is coming 20 microcoulomb because C is 2 microfarad. Then V1 is equal to Q by C1, V2 equal to Q by C2. Energy stored here, U1 is equal to Q square by 2C1, U2 is Q square by 2C2. Total energy stored is U1 plus U2. The two capacitors connected in parallel and the group is connected across the battery. This group is equivalent to a single capacitor, capacitance C. So C is equal to C1 plus C2 is coming 9 microfarad. Here what is V? Here the same V. Charge Q2, charge Q1. So Q is equal to Q1 plus Q2. Its potential difference V. Its potential difference also V. Q1 is equal to C1V. Q2 is equal to C2V. Then the energy stored here, half C1 V square. Energy stored here, half C2 V square. We can also apply other formula for finding the energy, like Q square by 2C or half QV. Any formula is applicable. The total energy is equal to E1 plus U2. That is also half C V square or Q square by 2C. 3 capacitors, 2 microfarad, 3 microfarad, 6 microfarad are connected in series, and that group is connected across 240 volt supply. Charge Q, here Q, here Q, the effective capacitor, charge also Q, potential difference V1, V2, V3, V is equal to V1 plus V2 plus V3, Q is equal to CV, because C formula is coming 1 microfarad. This is the series grouping. C formula is coming 1 microfarad. So Q is equal to CV. This Q also here, here and here. Then V1 is equal to Q by C1. V2 is equal to Q by C2. V3 is equal to Q by C3. Three capacitors, each of capacitance 6 picofarad, are connected in series, and that group is connected across 240 volt supply. This capacitance C2, C3 each has capacitance 6 picofarad. So the effective capacitor is coming 2 picofarad. Q, 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 here also Q. V1 potential difference, V2 potential difference, V3 potential difference, V potential difference, V must be equal to V1 plus V2 plus V3. So Q is equal to CV, C into V, Q found. Then finding Q, V1 equal to Q by C1, V2 is equal to Q by C2, V3 equal to Q by C3. Energy here, half C1 V1 square. Energy here, half C2 V2 square. Energy here, half C3 V3 square. Also you can apply any other formula for finding the energy. The total energy is U1 plus U2 plus U3, that is U equal to half CV square. Three capacitors, 2 picofarad, 3 picofarad, 6 picofarad are connected in parallel, and the group is connected across 240 volt supply. The three capacitors are connected in parallel, and that finally connected to the supply voltage up to 40 volt. So the capacitance is C1 plus C2 plus C3. The charge Q1 is C1V. The charge Q2 is C2V. The charge Q3 is C3V. V given 240 volt. The energy here, half C1 V square. The energy half C2 V square. The energy half C3 V square. The total energy is U1 plus U2 plus U3. that is also equal to half total C into V square. So graphically how potential varies with distance from A. Here the potential VA, here also VA, here also VA, here also VA. Then potential falls. So VA remains, then potential falls, then potential remains constant, again potential falls, potential remains constant, again potential falls, again potential remains constant. So here potential VA and here potential VB. In figure 1 and figure 2, 4 capacitors are connected across the supply voltage of 10 volt. This capacitor and this are in series, that is equivalent to a single capacitor. These two are in series, that is equivalent to a single capacitor. Q1 charge, here also Q1 charge, 3 microfarad, 6 microfarad, the series group gives 2 microfarad, 6 microfarad, the series group gives 3 microfarad. Here Q2, here also Q2. So Q1 equal to 2 microfarad into V is 10 volt. Q2 is 3 microfarad into V. So knowing Q1, then the potential difference V1 is equal to Q1 by 3 microfarad, V2 is Q1 by 6 microfarad, V3 is Q2 by 6 microfarad, V4 is Q2 by 6 microfarad. V is equal to V1 plus V2, also V is equal to V3 plus V4. The energy stored E1 is Q1 square by 2 3 microfarad, U2 is Q1 square by 2 6 microfarad, U3 is Q2 square by 2 6 microfarad, U4 is Q2 square by 2 into 6 microfarad. The total energy is U1 plus U2 plus U3 plus U4, that is also equal to this parallel group of capacitor, that is 5 microfarad. So the total energy is half into 5 microfarad into 10 volt whole square. These two capacitors are connected in parallel. These two capacitors are connected in parallel. This parallel grouping and this parallel grouping are connected to each other in series. So this circuit is equivalent to this circuit. Here charge Q1, here Q minus Q1, charge Q2, here Q minus Q2. So this C1 and C2 is equivalent to 3 microfarad, C3, C4, that is equivalent to 6 microfarad. V1 potential difference, same V1 potential difference between these two. V2 potential difference, same V2 potential difference between these two. V1, here also V1 between these two. V2, here also V2 between these two. These two capacitors charge Q. So this total charge is now Q. This total charge is also Q. That is why if Q2 is here, then here will be Q minus Q2. If Q1 is here, then here will be Q minus Q1. So these two capacitors is equivalent to a single capacitor. The capacitance is 2 microfarad. Charge is Q. So Q is CV. Then V1 is Q by C1. V2 is Q by C2. So V1 finding, then we can find Q1 is CV1. Q2 is CV2. Q minus Q1 is CV1. Q minus Q2 is CV2. Then the energy stored U1 is Q1 square by 2C or half C1 V1 square. Similarly, for the other capacitors, the total energy is U1 plus U2 plus U3 plus U4. That is also half CV square. Four capacitors are connected across supply voltage of 500 volt. Each capacitance is 10 microfarad. This is 10 microfarad. This is also 10. This is 10. This is also 10 microfarad. These three are in series. The effective is 10 by 3 microfarad. This 10 microfarad and 10 by 3 microfarad, they are in parallel. So the effective capacitance between this point and this point, the effective capacitance is 10 by 3 microfarad plus 10 microfarad. What is the charge Q1? Same Q1, same Q1, same is also here. So Q1 is 10 by 3 microfarad into V. Q2 is 10 microfarad into V. Then V1 is Q1 by 10 microfarad. Similarly, the V1 is same here, the V1 is same here. The energy stored U1 is Q1 square by 2C or half C into V1 square. So this energy equal to this energy equal to this energy. That is why here energy is 3 times of U1. Similarly, for this 10 microfarad capacitor, the charge is CV. The energy is Q square by 2C or half CV square. Six capacitors are connected across 10 volt. Then we have to find the energy, charge and other things. Charge Q1, series combination. So charge Q1, the effective capacitance 2 microfarad. Q2, Q2, Q2. This is 2 microfarad series combination. It is coming then 1 microfarad. This Q1 plus Q2 must be Q3. So Q3, 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 here also Q3, 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 Q3. Now these two capacitors are in parallel. That's effective capacitance is 3 microfarad. So 3 microfarad, 2 microfarad, 6 microfarad are in series. The effective capacitance is 1 microfarad. Since Q3, 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 here also Q3, V is equal to V7 plus V5 plus V6. So Q3 is equal to CV. Then solving Q3, V7 is Q3 by 3 microfarad. V5 is Q3 by 2 microfarad. V6 is Q3 by 6 microfarad. So solving V7, Q1 is CV, Q2 is CV. So Q1 we found, Q2 we found. Then V1 is Q1 by 3 microfarad. V2 is Q1 by 6 microfarad. V3 is Q2 by 2 microfarad. V4 is Q2 by 2 microfarad. Then energy E1 is Q1 square by 2C or half C into V1 square. Similarly, for the energy of the other capacitors, here the energies are, here the potential difference across different capacitors. Two capacitors of capacitances 5 microfarad, 6 microfarad are charged to potential difference 10 volt and 15 volt. Then they are disconnected from the battery and connected to each other with the positive plate of one joined to positive plate of other and the negative plate of one joined to negative plate of other. These two capacitors, after disconnected from battery and before they are connected to each other, C1 is 5 microfarad, C2 is 6 microfarad. It was connected, it was charged to 10 volt, it was charged to 15 volt. So the charge Q1 is 50 microcoulomb, the charge Q2 is 90 microcoulomb. The energy stored is half C1 V1 square is 250 microjoule. The energy stored is half C2 V2 square is 675 microjoule. The total energy is E1 plus U2 is coming 925 microjoule. Now we'll join this capacitor with this capacitor. This is the positive plate, this is the positive plate, they will be connected to each other. This is the negative plate, this is the negative plate, they will be connected to each other. So the connection is like this. Now the charge distribution will be different from the earlier charge distribution. Let here the charge is Q1, here the charge is Q2, this Q2 is Q1 plus Q2 minus Q1. So Q2 is Q1 plus Q2 minus Q1. In this combination, if V is potential difference across first capacitor, V is also potential difference across second capacitor. So V is Q1 by C1, V is also Q2 by C2. Putting this Q2 here and solving Q1, we get Q1 to be this and this. After putting the respective value, we got Q1 to be this much. Similarly, Q2 is this much. V is Q1 by C1 or Q2 by C2. So this is the formula. Then accordingly V coming 140 by 11 volts. Here the energy stored is half C1 V square. Here the energy stored is half C2 V square. Total energy stored is this much. This is the energy after the two capacitors are connected to each other. Before they were connected, the total energy was 925 microjoule. After they are connected to each other, the energy becomes 890.9 microjoule. So the loss of energy in the process of combination of the two capacitors is 34.1 microjoule. This problem you will solve by yourself following the previous problem. This problem also you will solve by yourself.